In this video, we're going to learn how to apply scale factors to real-life situations. But before we get into that, we have to learn how to solve when we have an unknown in a fraction which is equal to a fraction. So there's two ways of doing that. We could use proportional reasoning or we could solve it algebraically. So first I'm going to show you proportional reasoning and then I'm going to show you algebraically. So here I have 3/7 is equal to something over 28. So first I'm going to look at, I have a ratio here. 7 multiplied by what is equal to 28? Well, 7 multiplied by 4. Okay, so that must mean I must multiply my 3 by 4 as well. So 3 multiplied by 4, my x in this case is equal to 12. Let's try my next one here. Now my x is on the bottom. Here I have 54 multiplied by what gives me 6. So I could either go 6 divided by 54, my small number divided by my big number will tell me how I go that way. So 6 times 9 is equal to 54, so that means I must divide 54 by 9. Here, that means I must divide 45 by 9. And now if I divide 45 by 9, I'm going to end up getting 5. Alright, let's try my next one. It says solve algebraically. So now we're going to solve algebraically, so we're going to isolate for x. This is the way that I'm going to tend to do things. So first, all I'm going to do is multiply this by 216, and I'm going to multiply this side by 216. Now, I'm left with 216 divided by 9 is equal to x. And then we're going to end up getting 24 is equal to x. Let's try my next one. Here I have 4 over 3 is equal to 32 over x. Now this one, the x is on the bottom. So I'm going to multiply first both sides by x. So I'm going to be left with 4 over 3x is equal to 32. Now I'm going to multiply both sides by 3 over 4. So now I'm going to be left with x is equal to 32 divided by 4 is going to be 8 times 3 is 24. Okay, so now that we're done those, let's get to my first example. So my first example, we're going to try and determine the new dimensions of this beetle. So my beetle is 2.5 centimeters long by 0.75 centimeters wide and 1 centimeter high. For a science fair, you're going to make a large model of the beetle. So what would the dimensions of your model be if you use a scale factor of 15 over 2? So remember, my scale factor is equal to my image divided by my object. So in this case, my image is 15 and my object is 2. And here we know what my original is. My original is going to be equal to 2.5. And we're trying to figure out what will be my image because that's going to be my model. So now I have my fraction is equal to another fraction. So we have 15 over 2 is equal to my image over 2.5. I'm going to use the algebraic way because I personally like using the algebraic way better, but you guys can now use proportional reasoning if you want to solve this. The hardest part is setting it up. So I'm going to now, we want the I by itself, so I'm going to multiply both sides by 2.5. So 7.5 times 2.5 is going to give me 18.75. So we found one there. Now let's find my other one. So once again, we have 15 over 2 is equal to, we have now image for my other side is over 1. So here, I'm just going to have to multiply both sides by 1. Now this is going to end up giving me 15 over 2, which is 7.5, is equal to my image. I should also put these are centimeters. Now my last dimension is 0.75, so I'm going to have 15 over 2 is equal to I over 0.75. So once again, I'm just going to isolate for I by multiplying by my denominator. So I get 0.75 multiplied by 7.5 will give me I. And that ends up giving me 5.625. Okay? Now, let's try part B. If my scale factor is 20, what will his dimensions be? Now let's try part B. So here, my scale factor is equal to 20 over 1, because my image will be 20 times bigger than for every 1. Now we're going to go 20 over 1 is equal to, so we're first going to do the I over 2.5. So we want I by itself, solve algebraically, multiply by 2.5, multiply by 2.5. That's going to end up giving me 50 is equal to I. Now let's try my other dimension, which was 1. So we have 20 over 1 is equal to I over 1. In this case, I multiply both sides by 1. So I get I is equal to 20 centimeters. And then my last one for my model, we're going to have 20 over 1 is equal to I over 0.75. So in this case, we have to multiply both sides by 0.75 to get rid of my denominators. So here I'm going to end up with 15 centimeters is equal to I. So we have my dimensions for all of them. So now what happens if we want to find the original instead of the image? Well, let's read this question and figure that out. So at the fair, a kid can ride a model seahorse that is 2 meters long. If the scale factor of the enlargement was 50, what is the size of the real seahorse in millimeters? We first are going to write down what is my scale factor. And that's 50 over 1. Now remember, my scale factor is my image over my original. Now we know my image is 2 meters long. So now when we write this, we have my proportion. So we're just going to go like what we did at the very beginning of class and solve for x. So my problem here is my x is in my denominator, and I need my x to be in the numerator. So what I'm going to do is I'm going to multiply both sides by x. Now I'm left with 50, x is equal to 2. So next I'm going to divide both sides by 50. So I get x is equal to 1 over 25, which is the equivalent of 0.04 meters. So we did ours in meters here, and it wants my answer in millimeters. So I'm going to have to move the decimal over 3 times. So this is equal to 40 millimeters, because it's the same as 4 centimeters. So in my next example, we have a jet that is 70 meters long and its model, which is 28 centimeters long. One thing to first note is one's in meters, one's in centimeters. So in other words, this meter is the same as 7,000 centimeters. So my scale factor is equal to my image divided by my original. My original is the actual jet, which is 7,000, and my image is 28. Now I'm going to simplify this fraction. It's a lot of times easier to work with smaller numbers. So I'm going to prime factor each of them. So I'm going to get 2 times 2 times 7 all over 7 times 2 times 5, which is 1 0, times 2 times 5 times 2 times 5. Now we're going to start canceling off here. I have 7 and 7 is gone, 2 and 2 is gone, 2 and 2 is gone. So I'm left with 25 times 2, which is 50. So this is the same as 1 over 50. So now we know my scale factor. My first question says, on the model, the wingspan is 24 centimeters. What will be the wingspan on the actual jet? So I have 1 over 50 is equal to 24 over x. So once again, x is my denominator, so I'm going to try and get rid of this denominator by multiplying by x, multiplying by x. So now I get x over 50 is equal to 24. Now all I'm going to do is multiply both sides by 50. So I end up with my x is equal to 1,200 centimeters, or 12 meters. Now part C says the model of the tail is 7.6 centimeters high. What is the height of it on the actual jet? So once again, my scale factor is 1 over 50. must be equal to 7.6 all over x. We can use also proportional reasoning for this. So right here we multiply by 7.6. That means here I can multiply by 7.6 as well. So we have 7.6 and we have 7.6. So 50 multiplied by 7.6, we're going to end up getting x is equal to 380 centimeters, or 3.8 meters. Now, our last question has a scale diagram of an enlarged image of a totem poles 1 to 50. So that means my scale factor is equal to 1 over 50. So it's normally going to be image and then object. So what is the height of the actual photo? You know it's 10 centimeters, so my top is 10 centimeters, and we want to figure out what is my bottom. So once again, I multiply this by 10. I'm going to multiply this by 10. When it's just 1 to get to something, it's a lot easier just to multiply and use our proportional reasoning. So I'm going to end up getting x is equal to 500 centimeters, or 5 meters.